Hi, welcome. This is a lesson on trigonometric ratios. Um, First off, we need to talk a little bit about the triangles. They're right triangles. When we're talking about these trig ratios, we're talking about right triangle trigonometry. And so we need to know, we often use this as a variable. This is the Greek letter theta, and it's just like any variable, but we usually use it for angle measures. That's where it's most commonly seen in math classes. So in angle measures. All right. So if we've got the angle up here, the side opposite the right angle is always the hypotenuse, and then each of these are legs. This one right next to means adjacent. So we have the adjacent leg, and then opposite that angle is uh, the opposite leg. If I put theta down here, the hypotenuse does not change. It's still opposite the right angle. But the opposite leg is now over here. This is then the opposite leg, and right next to it is the adjacent leg. Okay, so the sign, so we've got this pneumatic, so katoa. I like to write it like this. So katoa. And the sine of a given angle theta is the O over H, or the opposite leg over the H, which is the hypotenuse. And then we've got the cosine, and the cosine is ka, that's the so ka, CAH, and that's the cosine of theta is the adjacent over the hypotenuse. And then we've got the toa, O over A, that's the tangent. And the tangent of theta is the opposite leg over the adjacent leg. That's the tangent of a given angle. And once again, the cosine is the adjacent over the hypotenuse, and the sine of the angle is the opposite over the adjacent. And we usually write this as sin, but even though we write it like sin, we don't say sin, we say sine, the sine of theta. And here, this is the cosine of theta. This is how we write it, how we say is cosine of theta, and then tan is tangent of theta. And so just like you wouldn't see this and say you read that as etc. Same thing with sine, cosine, and tangent. Okay, the cosecant is the opposite of so the cosecant of theta is the inverse of the sine, and so it's the hypotenuse over the opposite leg. And the secant of theta is the opposite of the cosine, and so it's the hypotenuse over the adjacent. So it's just flipped, right? And the cotangent of theta is the opposite of the tangent, and so that would be the adjacent leg over the opposite leg. All right. So identify the three trig ratios for the triangles in the examples below. Example 1. It's a good idea to label. This is H for hypotenuse. Here is my angle theta, and so this is O for the opposite. And right next to it is A for adjacent. Start with your hypotenuse always, because then it's easier to say, okay, this is the adjacent because it's the adjacent leg. It's one of the legs next to the adjacent means next to. Okay, so sine of theta, that's O over H, 8 over 17. And cosine, that's cos, A over H, that's 15 over 17. And tangent, that's O tsokatoa, O-A, that's 8 over 15. And then we've got the cosecant, and the cosecant goes with the sine. And so it's just 17 over 8. And the secant goes with the cosine. And they are just the reverse, so it's 17 over 15. And then we have the cotangent, and the cotangent is the opposite of the reciprocal of the tangent. And so it's 15 over 8. All right, let's look at the next one. Once again, we're going to, this time they didn't give us, this time they didn't give us the hypotenuse. And so we're going to use a squared plus b squared equals c squared, with c being the hypotenuse, and that's what we're looking for. And so a is 10 squared plus 20 squared equals c squared. 10 squared is 100. 20 squared is, 400. And that's equal to c squared. And so we get 500. So c squared equals 500. Then taking the square root of both sides, c then is equal to the square root of 500. And if I want to simplify that, I can write that 500, 2 goes into 500 250 times, and 2 goes into 250 125 times. 5 goes into 125 25 times. 5 into 25 goes 5 times. And so I see I have one pair of 5s and one pair of 2s. So a 2 and a 5 are going to come out as a 10. So this is equal to 10 square root of 5. 10 square root of 5 is our hypotenuse. And it's asking about A. And so I can put a theta there to help me remember that this is opposite. This is adjacent. So the sine, O over H, that's 10 over 10 square root of 5. And cosine, is A 20 over 10 square root of 5. And the tangent, O over A, toa, that's 10 over 20. And you'd want to simplify these as you can, but right now this is just the basic idea of what these ratios are. So the cosecant is 10 square root of 5 over 10. The secant is 10 square root of 5 over 20. And the cotangent is 20 over 10. All right. Now, example 3, we've got to kind of work backwards from this. They've given us the tangent. And so we're just going to make a random triangle with a right angle here. I'm going to call this B. And I know that my tangent is 12 over 5. And so I can say tangent, that's toa, O over A, toa. So my opposite is 12. I can put 12 right there. And A is 5. The adjacent angle is 5. And so once again, we're going to say 12 squared plus 5 squared equals, I'm going to just say h squared for the hypotenuse. You could say c squared if you'd prefer, that's fine. 12 squared is 144. 5 squared is 25. 144 plus 25 would be 169. Equals h squared. And then take the square root of both sides. H then is equal to 13. And so then I can label this as 13. I can label 13 as being h, the hypotenuse. Now it says theta here, so I'm going to assume that theta is my b. So we'll say that's b, and b is theta. It's the same thing there. Theta is the angle measure of b, we'll say. And so sine of theta, that means this is O for the opposite, and A here is for the adjacent. And so O over H is 12 over 13. And Ka, cosine, that's A over H, that's 5 over 13. Tangent, O over A, we were given that, that's 12 over 5. The cosecant is 13 over 12. The secant is 13 over 5. And the cotangent is 5 over 12. All right, and then finally, example 4, we got the cosine of theta equals square root of 3 over 2. So once again, we're just going to make a random kind of triangle here. I'm going to label this as theta. Cosine is, so ka, it's a over h. And so I put the adjacent over the hypotenuse. This is the hypotenuse 2. I'm going to label it as the hypotenuse. And write square root of 3 then. The square root of 3 is right here, and that's my adjacent leg. And so I need to figure out what this is. So I say a squared plus b squared equals c squared. But this time we know the hypotenuse. And so it's 2 squared is equal to a squared plus the square root of 3 squared. So then what do we got? We got a squared plus 3 equals 4. A squared equals 1. Take the square root of both sides. A equals 1. All right. So this is 1, and we're going to label it as O for opposite. Then we've got the sine. So is O over H. That's 1 over 2. And ka, the cosine, we've already got that. They gave it to us as a square root of 3 over 2. The tangent is 1 over the square root of 3. The cosecant goes with the sine, and so that's 2 over 1, or just 2. The secant goes with the cosine, and that's 2 over square root of 3. And then we've got the cotangent, and that's the square root of 3 over 1. And that's how we do it. Go ahead and practice.